Welcome to this explainer. Today, we're breaking down the engineering philosophy behind two incredibly different AI agent architectures. We're looking at a classic David and Goliath matchup in the AI world, exploring how two completely divergent approaches to code-based size and orchestration attempt to solve the exact same problem, building a highly capable autonomous AI assistant. Let's get into it. Here's a quick look at our roadmap. First up, we'll outline the two main approaches to AI agents. Then we'll dive deep into Hermes, the enterprise heavyweight, and explore its flexible sandboxing. After that, we'll switch gears to look at Nanobot, the minimalist challenger. Finally, we'll wrap up by comparing the two to see if a heavyweight or featherweight approach makes sense for you. All right, Section 1, two approaches to AI agents, the architectural divide. So here's a question for you. Do AI agents really need massive code bases? We often just assume enterprise systems naturally need hundreds of thousands of lines of code to be robust, secure, and actually useful. It's that traditional software engineering mindset, the idea that more features absolutely require more code, more abstraction, and heavier frameworks. But today, we're going to put that theory to the test. Is all that complexity actually giving us necessary power, or is it just creating sluggish bloat? It's a debate that's literally shaping how the next generation of autonomous tools will be built. Let's move right into Section 2, Hermes, the enterprise heavyweight, power and complexity. So Hermes is what you'd call a true heavyweight framework. It relies on a massive file that orchestrates absolutely everything behind the scenes. This file is known as the agent loop. Think of it like a highly structured command center. It doesn't just pass text back and forth to a large language model. Oh no, it handles complex prompt assembly, meticulously manages your conversation history, dispatches tools, and even handles fallback model switching. Like if an API provider suddenly goes offline, Hermes has your back. It leaves absolutely nothing to chance, ensuring the system is always actively managing the state of your AI. To maintain that absolute control, Hermes enforces a very strict turn lifecycle. It acts like a rigid traffic cop. It never ever allows two assistant messages in a row, and it never allows two user messages in a row. It's totally sequential, user, assistant, tool, assistant. When the model returns a tool call, that tool must be executed, and the result has to be returned to the assistant before the user can even jump back in. Why? Well, API providers will often reject malformed histories, so Hermes forces this incredibly strict structure to keep the data clean and prevent catastrophic crashes mid-task. Now, in an enterprise setting, context windows fill up fast. To handle that memory, Hermes triggers what it calls a pre-flight compression the exact moment you hit 50% of your model's context window. If you keep going and push it to 85%, a much more aggressive gateway auto-compression kicks in between turns. It automatically flushes your memory to the disk, summarizes the middle of the conversation, and perfectly protects your most recent messages so the agent never loses its train of thought. This proactive management is brilliant because it saves compute resources and stops you from hitting those hard token limits during really complex jobs. Here is an absolutely crucial point. Hermes ensures incredibly clean data by completely abandoning responses if the user interrupts with a new message. If the AI is mid-thought, right, and you send a stop command or fire off a new prompt, Hermes doesn't just pause. It completely discards that partial response. This guarantees that no messy, half-finished thoughts or hallucinated code fragments ever get injected into your permanent conversation history. It keeps things spotless. Moving on to Section 3, Flexible Sandboxing with Hermes. 6 terminal backends. Hermes gives you an incredible 6 different terminal backends, ranging from direct local execution all the way up to highly secure cloud sandboxes. You can run code locally, which sure has zero isolation, or you can use Docker for a nice, hardened local sandbox. If you need remote power, you can use SSH. For scalable cloud compute, it integrates natively with Modal and Daytona. And get this, if you're working on massive high-performance computing clusters, it even supports Singularity containers. The flexibility here is just immense, letting developers deploy the agent in virtually any security environment they could possibly require. But let's dive into this real standout feature of the Docker backend. Hermes Docker containers actually persist. They don't just spin up, run one single command, and instantly die. No, Hermes routes every single terminal and code execution call through one long-lived container. This means if your agent starts an NPM watcher, a dev server, or some background Python process, it actually stays alive between tasks and even across sessions. It's an unbelievably powerful feature for continuous development, making the AI feel so much more like a human coworker sitting at a real machine. All right, time to pivot. Section 4, Nanobot, The minimalist challenger, agility and speed. Just 4,000, that's it. That is literally all it takes. Nanobot achieves core AI assistant capabilities with just 4,000 lines of Python code. There are no massive orchestration engines here, no deep, confusing abstraction layers. It strips away all of that enterprise bloat to focus purely on the essential logic required to make an agent function effectively. It is an incredible exercise in raw minimalism that proves just how lean these systems can actually be. To put that into perspective, that is a staggering 99% reduction in codebase size compared to standard enterprise AI systems like OpenClaw. 99%. It totally challenges the industry assumption that building a reliable AI agent requires a massive, complex software foundation. Fewer lines of code naturally means a drastically smaller surface area for bugs, making it remarkably easy for a single developer to read, audit, and understand the entire architecture in just an afternoon. When you look at the performance data, it's wild. Nanobot features a blazing fast 0.8-second cold start. While heavier frameworks are taking 8 to 12 seconds just to boot up, Nanobot is basically instant, and the memory footprint, just a mere 45 megabytes, compared to the 200 to 400 megabytes demanded by the heavyweights. If you need to deploy an agent in a really resource-limited environment, like a Raspberry Pi, or if you want to spin up dozens of instances all at once, this kind of efficiency is an absolute game changer. But honestly, don't let that tiny size fool you. Despite its small footprint, Nanobot still supports powerful, real-world features right out of the box. It's got built-in integrations for messaging apps like Telegram, WhatsApp, and Fishu, and even supports voice transcription via Grok Whisper. It seamlessly handles cron-based task scheduling for things like daily briefings or market monitoring. Plus, it lets you switch effortlessly between local and cloud LLMs, like jumping from OpenRouter directly over to Anthropic, without making you change a single line of code. So let's say you want to build a custom crypto tracker. With Nanobot, you essentially act as a pair programmer. First, you start the interactive agent mode. Next, you just prompt the agent in natural language to build the tool for you. And finally, you simply run the generated Python script. Because the framework is so lightweight and modular, the agent easily understands its own environment and can write functional, executable tools for you in just a few quick conversational turns. It's that easy. Okay, final section. Section 5, heavyweight or featherweight, choosing your paradigm. So what does this all mean for you? Well, it really comes down to choosing between Hermes' massive scale orchestration and Nanobot's lightning-fast minimalism. Hermes gives you deep, secure sandboxing, rigorous context compression, and strict session management. It's built like an absolute fortress for massive scale. Nanobot, on the flip side, strips all that away to give you ultimate agility, speed, and a highly maintainable codebase. It operates like a rocket ship, perfectly optimized for rapid prototyping and edge deployments. And this architectural choice directly impacts your daily velocity. Because of Nanobot's stripped-down nature, your development time for custom features drops dramatically. Adding a brand new tool in Nanobot takes roughly 15 to 30 minutes. In contrast, registering a new capability within the complex abstractions of a heavyweight framework can easily take several hours of development, tracing through deep directory structures and dealing with debugging. So as we wrap up this explainer, the ultimate question isn't really which framework is objectively better. It's about which philosophy actually fits your next big project. Do you need the ironclad, deeply orchestrated security of a Goliath like Hermes, or the agile, resource-friendly iteration of a David like Nanobot? Think about your specific constraints and let that guide your choice. Thanks so much for exploring these fascinating architectures with me today. And whatever you choose, keep building.